Hey y'all, it's Andrew Couch here. I'm a data scientist, and today I'm going to be reacting to AI and machine learning in movies. Our first movie is Ex Machina.
Do you know what the Turing test is?
Yeah, I know what the Turing test is. It's when a human interacts with a computer, and if the human doesn't know they're interacting with a computer, the test is passed.
And what does a pass tell us?
That the computer has artificial intelligence. Are you building an AI?
I've already built one. And over the next few days, you're going to be the human component in the Turing test.
Holy shit.
Yeah, that's right, Caleb. You got it. Because if that test is passed, you are dead center of the greatest scientific event in the history of man.
If you've created a conscious machine, it's not the history of man. That's the history of gods.
So, in Ex Machina, they're obviously creating a machine, and this machine is an AI. And how we test this is we're trying to convince a human that this machine is human, when in reality it's just a model or whatever. So this is actually a pretty famous test, I guess, among like computer science and people who are really kind of like studying technology. That being said, for most data scientists on the day-to-day, you're not really going to experience a lot with like Turing tests and stuff like that, although it's very fancy and a nice little thought experiment. Most of the time, we're actually working with like basic models to do simple predictions. There is a common thing with people using AI and machine learning interchangeably. For me, I think there's a little bit separate differences. So we have data science as its entire, I guess, group, and then we have AI machine learning in data science. But AI is machine learning, but machine learning is not AI. So machine learning, we're always thinking about is like basic models like linear logistic regression. You have your tree-based models like random forest and XGBoost and stuff like that. But what differentiates AI is really working with like unstructured data. So when we're thinking about using AI is for like text data, sound, images, and video, and that really encompasses neural networks. So neural networks are mostly kind of associated with AI, and not even just neural networks, but deep learning. So deep learning is essentially a neural network with a lot of layers. Generally, I think we call deep learning more than 3 layers, but it's there's not a set rule. So when we have a lot of deep learning, we generally say like AI and stuff like that. But for me, I generally try to keep it towards just machine learning. I think AI has some connotations of like trying to sell something, especially with these new tech companies that they have this new AI. When in reality, it's some type of like BERT model, right, from Google. So in general, you'll hear it thrown around. You'll hear AI in a lot of like product presentations, stuff like that. But I think most data scientists don't really talk about saying like AI. They say machine learning or deep learning. This kind of addresses a lot of like interesting quirks about data science. So the Turing test is all about like how can we kind of reach the new milestone in machine learning. But there are definitely a lot of discussions that are pretty good thought experiments. So I think that kind of comes to mind, especially like in the past few years, is the baby in the street with autonomous cars. So like Tesla. One of the scenarios is like, hey, you see a baby on the road and a autonomous vehicle is driving. Does the autonomous vehicle swerve and avoid the baby, or does it kill the baby? And this is a pretty good, it's a good thought experiment about, hey, how should we program and develop philosophical ideas into these models? But at the end of the day, I think we also have to think about how data science is kind of a product-oriented disciple or discipline. So when we're trying to create these products, generally we're trying to dealing with like who is going to be using these products, and generally who are people going to be using these products, such as autonomous vehicles, are people who want to buy the car. So if we were to create a product that would kill the consumer, then no one would buy it. So just a common, more straightforward way to think about it is, hey, it would save the driver and kill the baby in this made-up scenario, because no one would want to drive a car that would prioritize someone else over themselves. So that's just kind of a little common thing that we hear a lot. And I think that's a pretty simple way to view a lot of these ethical decision makings. Obviously, I've kind of reformatted the question into way more of a applied and not really philosophical, but it is something that's kind of interesting that kind of makes me roll my eyes when I hear these kind of debates. But again, it's not a bad thought experiment, but it's something that's not really used a lot in applied data science. That being said, ethics in data science is a huge issue. It's not really taught in data science classes, and most data scientists haven't really taken an ethics class on ethical uses of data, which is something that society as a whole, or at least academia, needs to address. Okay, next clip.
So we need to break the ice. Do you know what I mean by that?
Yes.
What do I mean?
Overcome initial social awkwardness.
So let's have a conversation.
Okay. What would you like to have a conversation about?
Why don't we start with you telling me something about yourself?
What would you like to know?
Whatever comes into your head.
Well, you already know my name. And you can see that I'm a machine. Would you like to know how old I am?
Sure.
I'm one.
One what? 1 year or 1 day?
One.
When did you learn how to speak, Ava?
I always knew how to speak. And that's strange, isn't it?
Why?
Because language is something that people acquire.
Well, some people believe language exists from birth, and what is learned is the ability to attach words and structure to the latent ability. Do you agree with that?
I don't know. Will you come back tomorrow, Caleb?
So in this scene, they're talking about associating text with meaning. And that's actually a common thing of how we actually create these AI or text models. In the field of text, or as the process of language, we have two different distinctions, NLP and NLU. So NLP is natural language processing, and it's all about making, models and just like basic text analysis. So with models, a common thing that we do, or a common starting place, is a model to predict ratings using IMDb review text, right? For text analysis, we have a bunch of different methods like topic modeling, so getting all this text and creating topics from it. We also have like sentiment analysis, so associating positive and negative sentiment to it. And we also have like just basic processing of text data using bag of words or n-grams, which are like a pairings of words. As for NLU, which is called natural language understanding, it's more about how models can comprehend words and kind of have their relationships paired with each other. With NLU, we do a lot of like topic summarization. So we have a model read an article and kind of summarize it. We also have like question answer models. So you ask it to say like, when is my bill due, and it'll return an answer. And also text generation, which is used a lot, obviously, in these AI movies, where this model is essentially receiving text and generating new text from it as like a conversation. What's actually interesting is that language models, or NLP and NLU fields, are growing, and the technology is advancing by a pretty fast rate. I have these two examples of basically how we can combine words and kind of pair them up to have like similar meanings between the words, and how these models actually do it. So one of the main ways we do this is by using embeddings. And embeddings are basically compressing all these words into these values and having them put into a latent space or kind of a dimension. And right here on the left is the most basic way. It's called word-to-vec embeddings. And as you can see, what it's doing is it's associating queen and king as they're closer to each other than woman and man. But as you can see, queen and women are close to each other. Queen and king are close together because they're all kind of about royalty and also about gender. We can see vice versa, where king and man and king and queen are close together, but if you notice, queen and man are very far away, and king and woman are far away. So that's a good way to basically associate these synonymous words together. But now in these like newer language models with like modern AI, we usually use like neural network embeddings. So on the right is an example of TensorFlow embeddings. And right here, it's basically mapping up all these points. And in this case, it's using essentially the embedding values. So embedding values at the end of the day are just numbers with different dimensions. And they're doing basically using these embedding values, we're finding the nearest points next to a specific word that's associated with that embedding. So in this case, they're finding the word important and find the nearest words to it using the embedding values. And as you can see, we have like significant, particular, essential, vital. All of these words are the closest to it, the word important, and they're very synonymous with each other. So we can see how these models are actually pretty good at putting almost like synonymous words together, which can then translate to like actual understanding of these words. Even though I have to preface is that these models aren't really understanding the words, they're just kind of looking at the word associations together and pairing them up to the distance to each other. So the distance and the relative usage of the words are basically created using embeddings that can also simulate as being like understanding using synonyms. But it's a great movie about kind of like these ethics of it, and we're getting a little bit closer, but it's a little too out there in the future for what we have right now. Okay, our next movie is Her.
Oh. Hi.
Hi. How you doing?
I'm well. How's everything with you?
Pretty good, actually. It's really nice to meet you.
Yeah, it's nice to meet you too. Oh, what do I call you? Do you have a name?
Yes. Samantha.
Really? Where'd you get that name from?
I gave it to myself, actually.
How come?
'Cause I like the sound of it. Samantha.
Wait, when did you give it to yourself?
Well, right when you asked me if I had a name, I thought, yeah, he's right, I do need a name. But I wanted to pick a good one, so I read a book called How to Name Your Baby, and out of 180,000 names, that's the one I like the best.
Wait, you read a whole book in the second that I asked you what your name was?
In 2/100ths of a second, actually.
So do you know what I'm thinking right now?
Well, I take it from your tone that you're challenging me. Maybe because you're curious how I work? Do you want to know how I work?
Yeah, actually. How do you work?
Well, basically, I have intuition. I mean, the DNA of who I am is based on the millions of personalities of all the programmers who wrote me. But what makes me, me, is my ability to grow through my experiences. So basically, in every moment, I'm evolving. Just like you.
So in this movie or in this scene, they're kind of showing a more good representation of what we're kind of gonna see in the future. Obviously, Samantha is mostly a virtual assistant, like what we have right now, which is like Siri, Alexa, and Cortana. And what's actually very interesting about her is that natural speech processing is progressing very fast. So Siri definitely sounds more like a human every year, and language models are evolving. So it actually kind of plays a huge role in the future of virtual assistants and also how we interact with technology. For example, like with virtual assistants, people were kind of talking about how we should start saying like, please Siri, like Siri, can you please get my mail or my email and stuff like that, and no less demanding, so we can kind of teach people better manners and how we can interact with each other. That being said, in the scene they talk about how Samantha names herself. In general, that's actually pretty straightforward. When we generate new words with a trained model, we generally just generate a random number from that word, which will generate like a letter, and then it'll kind of continue generating random stuff with the most probable letter after those words, and that can generate like a name. One thing that's pretty interesting is that they talk about how Samantha, or this virtual assistant, was built, and it's just built by these programmers and developers who will use like other personalities, which you can associate with like text or text data and conversations. And yeah, that's a pretty straightforward way of how people make a lot of these language models. Additionally, or lastly, they talk about how once she's released to a person, then the model starts to kind of adjust and learn a little bit more from that person's behavior. And that's extremely accurate. That's how a lot of models are being used today. So that itself is what's called is transfer learning. Transfer learning is basically the idea is that we can use these models that were developed using millions and billions of data, and then basically adding another layer to it and letting that layer be adjusted to serve our needs. So stuff like specifically like computer vision. I don't have a lot of images. I don't even have an NVIDIA GPU, but Google was able to create a lot of models using all these images that are labeled, and I can use Google's model, freeze all of the weights in the coefficients from that model, add another layer, and use that layer to basically tune a model to whatever problem I have. So in this case, they're just cutting off the end of the model, adding another classifier to it, which is in this case is a support vector machine, and using that to make predictions. So again, I think Her is probably one of the most accurate AI machine learning movies for the future and what we can see from. So great movie and a great clip. Our next movie is 2001: A Space Odyssey.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
So this is a commonly referred scene when we're thinking about the dangers of machine learning, right? So Hal, and just to give a little context of Hal, Hal is IBM. If we increase the letters by 1 for each letter in Hal, it means IBM. And I think the general idea is like, can models go off on their own and destroy the world? Scenario is that models obviously are trying to optimize some type of function. And one of the things that they're talking about is, hey, we're going to have a model or AI that'll reduce sickness in the world. And how the model decides to reduce sickness is essentially to kill everyone. And this is kind of not really sensical with how we actually use models. At the end of the day, when we create models, it's just generating a single output or like a probability or a value. And most models are just good at just doing one specific thing. And in general, models are just never stand alone. So generally, people will use a model to predict something or to evaluate something, and then we're going to actually build infrastructure around it. That being said, there are a lot of dangers with using models, specifically with unintended consequences. So one thing that we have to deal with is like, what type of data are we feeding into our model, and what about like negative feedback loops? So one common example is like chatbots. When I think IBM maybe or Microsoft released a chatbot, they let people interact with it, and after like a few days, the chatbot was saying a lot of derogatory and racist things, and that is a function of basically how the internet was interacting with these chatbots. They were saying curse words to it, and then when they use that data to input in the chatbot, and then the chatbot starts regurgitating what words were inputted into it. So again, it is something that people need to be cognizant of, specifically of like the quality of data and how this data is going to be interacted in our systems that when we're gonna release a product. But it's not going to go off and kill people. In the end of the day, people are going to be writing stuff around the model, and that can cause a lot of problems. But the model itself is not just going to go off on its own and do something else and kill people, hopefully. But yeah, good clip. We'll go to the next movie, which is Moneyball.
So using this equation on the upper left right here, I'm projecting that we need to win at least 99 games in order to make it to the postseason. We need to score at least 814 runs in order to win those games. and allow no more than 645 runs.
What's this?
This is the code that I've written for our year-to-year projections. This is building in all the intelligence that we have to project players.
Okay.
It's about getting things down to one number. Using stats the way we read them, we'll find value in players that nobody else can see. People are overlooked for a variety of biased reasons and perceived flaws. Age, appearance, personality. Bill James and mathematics cut straight through that.
Okay, so I loved Moneyball. I think Moneyball is like the most accurate way of like what data scientists actually kind of do, or data analysts actually do. That being said, obviously it's based off of a real story, so that's why it's a little bit more accurate. But as you see right here, what he was saying, or what Jonah Hill's character was saying, was that it's they're creating these metrics to evaluate players. And right now in the modern day, we do have we're continuing on this process of evaluating players based off their statistics, based off their data, and maybe we're relying a little bit less on visual and personality and stuff like that. Although those do play a huge role, we have a little bit more objective measures where we can use these to rate players. Sports data itself is actually very nice for practicing your own data science work. It's highly available, highly clean, and obviously this sports data follows a lot of distributions or common distributions, so we can do a lot of like rudimentary statistics on it and get a lot of value out of it. That being said, it was kind of interesting to see how there was a lot of like value generations in the scene. And that kind of follows a lot of this modern way of data analysis, or at least like data forecasting, which is using a lot of Bayesian inference. In Bayesian inference, we use things like STAN, BRMS, JAGs, and bugs to basically create projections of data. A common forecasting thing with Bayesian inference is like presidential election forecasts. So very good video, kind of shows what we kind of look at, and also like how we kind of use our data to do actual work and actual impact into what we're trying to do. These charts are always from our Raptor metrics, which is a pretty common metric used in basketball. And we can see, we have our Raptor stuff, and we see like a player evaluation with their Raptor scores. In this case, it's Steph Curry. So yeah, this is a pretty accurate, is completely accurate scene, and we're still doing it today. Our next movie is The Imitation Game.
Yes, Alan?
Why do you think your German counterpart has a girlfriend?
It's just a stupid joke, don't worry.
No. Tell me.
Well, each of his messages begins with the same 5 letters. C-I-L-L-Y. So I suspect that Silly must be the name of Fizzamore.
Is it possible the Germans are instructed to use 5 random letters at the start of every message?
Well, this bloke doesn't.
Love will make a man do strange things, I suppose.
In this case, love just lost Germany the whole bloody war.
So in this scene, they talk about basically doing some pattern recognition. As for data scientists, we don't really do a lot of like cryptography, but what they were talking about is using these finding patterns, or essentially a shared word across all these documents. And it really reminded me of using a common weighting scheme with text data called TF-IDF, which is called the term frequency by inverse document frequency. And this, I guess, like algorithm or weighting scheme, it measures how often a word is said and how rare it is between all of the groups. This is very good for like machine learning when we're trying to find words that can kind of separate and be highly predictive for classes. But it's also able to find, hey, what are the words that are used by all the groups? And stuff like this is a very simple algorithm, and it's very useful in your day-to-day basis. But again, I don't do a lot of cryptography. I don't think a lot of data scientists do a lot of cryptography. I think it's more of a mathematician type of thing. But it kind of reminded me of this algorithm or this weighting scheme, and I just like to share that metric. So our next scene, or our next movie, is Margin Call.
Peter, is this your work? Most of Mr. Dale's.
But is this your draft?
Yes. Again, expanded on the original work by Mr. Dale, but yes.
What's your background?
My background?
Your CV?
I've been with the firm for 2.5 years working with Eric that whole time, but I hold a doctorate in engineering, specialty in propulsion from MIT with a bachelor's from Penn.
What is a specialty in propulsion exactly?
My thesis was a study in the ways that friction ratios affect steering outcomes in aeronautical use under reduced gravity loads.
So you're a rocket scientist?
I was.
Interesting. How did you end up here?
Well, it's all just numbers, really. Just changing what you're adding up, and to speak freely, the money here is considerably more attractive.
Oops. So in this scene, they're talking about a quant who's working at an investment firm and with an engineering background. And the reason why I wanted to show this scene is this is actually very common in data science. Most data scientists don't have data science degrees. They come from various backgrounds. In fact, it's actually pretty common to see people with PhDs in psychology pivot into like a data science tech career because, for one thing, psychology is an extremely crowded field, and the salary isn't great. So people do a lot of pivoting to data science from like engineering, economics, stats, psychology, chemistry, biology backgrounds, like pharmaceutical backgrounds and stuff like that. And it's something to always kind of keep in mind because most data science techniques is just statistics which are found in other industries. They might be named a little bit differently, but it's very easy to pivot from other industries as long as you are good at like looking at data, manipulating data in a programmatic way, and that's replicable. You can become a data scientist very easily from just pivoting. Okay, next scene is Minority Report.
Well, let's not kid ourselves. We are arresting individuals who have broken no law.
But they will. The commission of the crime itself is absolute metaphysics. The precogs see the future, and they're never wrong.
But it's not the future if you stop it. Isn't that a fundamental paradox?
Yes, it is. You're talking about predetermination, which happens all the time. Why'd you catch that?
Because it was going to fall.
You're certain?
Yeah.
But it didn't fall. You caught it. The fact that you prevented it from happening doesn't change the fact that it was going to happen.
You ever get any false positives? Someone intends to kill his boss or his wife, but they never go through with it. How do the precogs tell the difference?
Precogs don't see what you intend to do. Only what you will do.
So in this scene, they're talking about basically this oracle or thing that makes predictions on like murders. And they're talking about, hey, what happens if we falsely convict someone or falsely predict that someone is going to murder someone and just arrest them before they actually do it? Were they actually going to make the murder? And this is actually a common thing, not with predicting murders, but it's a common thing about how we assess models and their accuracy when we're making predictions on whether someone's going to do something or not. So like with the binary outcome. In this specific case, this is actually a very interesting problem with classification models. When we're dealing with imbalanced data sets where, you know, our positive outcome is very small. So in this case, a positive outcome or a positive prediction is a murder. Generally, people don't get murdered, right? So the class imbalance is very high. In fact, our conventional way of predicting accuracy is, you know, our predicted murders and predicted non-murders over the total sample will be highly skewed because we just say no one's going to murder each other and get like a 99.99% accuracy. Luckily, we actually have different metrics to assess this. As you can see right here, this is a confusion matrix and it's showing basically all of the metrics that we kind of create or conventional metrics that we use to assess our model's predictions. At the end of the day, it's just doing some adding and subtraction and a little bit of multiplication, but we can see that how we can use these true positives, false negatives, and true negatives, and do a little bit different arithmetic to get different assessments of our model. One thing that they're also talking about is when we make predictions on outcomes that have not happened, that's actually called like censored data. It's often used in survival analysis. So when we're trying to predict, you know, if someone has cancer, what's the, you know, survival rate for them to survive cancer through time. And oftentimes we have people who haven't died yet, so we're trying to model them out. So that's a common thing that we use in survivor analysis. One thing that we use is also like precision and recall. And that's a pretty good metric to use. So we have precision right here, and we also have recall right here. And we often use, if we have imbalanced data sets, is a ROC curve, which is the percentage or the comparison of the true positive rate with a false positive rate. And also we use precision recall curves, which is, the relationship between precision and recall given a specific probability. And we can use these as basically a better assessment of like imbalanced classes. Great. So our last movie is going to be The Social Network.
Perfect timing. Eduardo's here, and he's going to have the key ingredient.
Hey, Mark.
Eduardo,
You and Eric are split up.
how did you know that?
It's on your blog.
Yeah,
Are you alright?
I need you.
I'm here for you.
No, I need the algorithm used to rank chess players.
Are you okay?
We're ranking girls.
You mean other students?
Yeah.
You think this is such a good idea?
I need the algorithm.
Alright.
I need the algorithm.
Give each girl a base rating of 1400. At any given time, girl A has a rating RA and girl B has a rating RB.
When any two girls are matched up, there's an expectation of which will win based on their current rating, right?
Yeah. And those expectations are expressed this way.
Let's write it.
So in this scene, they're basically creating Face Mash, which is a site that compares women and ranks them. I love this scene because it kind of shows the double-edged sword of data science as a whole, and also kind of the beauties of data science. So the algorithm that they use is a basic ELO algorithm. It's used a lot, obviously, in chess, which they mentioned. It's also used in video games and sports, and it's a good ranking algorithm because we have these head-to-head matchups, and we can basically gain and lose points using this algorithm. And it's a good way to rank them. But why I talk about the double-edged sword is that, yes, it's beautiful that we can use these very simple algorithms that are used like in the 1800s, but also we can see how even though we can use these very elegant algorithms, it can cause a lot of harm to people. In this case, it's a very kind of gross way of using an algorithm by having these ranking of women. It's not very good, but it's something that we kind of have to consider. Again, data scientists need to kind of figure out, like, yes, we do a lot of work with data. We think about like models and ways to manipulate data, but there's also a thing where we kind of have to think about the ethics of data. And to me, this is a perfect summarization of modern data science. We're trying to use these algorithms to create these products, but sometimes these products can harm people. And it's very compelling that this is also Facebook, which has their own issues and stuff like that. But I also want to say is when we're thinking about using tools from our tool belt for a data scientist, in general, we will actually want to use a very simple model. Simple models are preferable. And I think ELO is kind of a good algorithm because it's very simple and it's very elegant and it's very useful for our own problem. I hope you guys like this video. I had a lot of fun making this, but I'll see you guys next time, and Tarian.